This is part 2 of section 6.1. We have been talking about factoring out the greatest common factor, and we've done a couple of easier problems, and now we're going to look at a couple of more difficult problems. So if you look at this is primarily an addition problem. And when I'm talking about overall what kind of problem it is, imagine that you could plug in numbers for your variable. Okay, if I had numbers, I would do this subtraction, then this addition, this subtraction, this addition. I would multiply those answers together, and then the very last thing I would do is an addition. So overall, this is an addition problem. If you look at this one, for the same reasons, overall, this is a subtraction problem. And if it's overall addition or subtraction, it is not factored. We want the very last thing you would do. If you could plug in a number, we would want that very last thing to be a multiplication in order to be factored. Okay, now this is a greatest common factor problem, but it's more complicated. What they want you to recognize is that we have the same thing here and here. Okay, so our GCF here is going to be the parentheses z minus 5. Now it's important that we're going to recognize the pattern of what's happening here. We are going to be distributing, it's just going to look more complicated. Okay, so when I go to factor this, we factor out our GCF, which is z minus 5. Okay, now I'm going to use brackets because I'm going to have parentheses within parentheses, and it's going to make it easier to match up. Okay, now just think of this here. This times what gives me this? Well, this times z plus 7 is going to give me this, right? This whole thing times this whole thing is right here. Okay, this is easier than you're going to want to make it. Plus, this times something gives me this. This times z plus 9. This times this is here. This times this is here. Okay, now let's simplify inside here. Here we're just adding two polynomials. There's no multiplications going on, so the parentheses don't even really matter. This is the same thing as z minus 5 times z plus 7 plus z plus 9. Now let's combine like terms in there. We have z minus 5. It times, I'm going back to parentheses because I don't have parentheses inside anymore. That's going to be 2z plus 16. Okay, so we have factored out our GCF, but have we factored it completely? You always want to look at the pieces you have left and to see if anything else can factor out. Here, there's nothing that divides evenly into z and negative 5. Okay, so this one's as good as it's going to get. But right here, both of these things are divisible by a 2. So this one alone has a GCF of 2. So I'm going to write this out, and this is a step that you would not normally write out. I'm doing this just so it's clear as to what's happening. Okay, I factor out that z minus 5, it's just right there. Now from this one, I can factor out a 2. So now pretend this isn't here. 2 times what gives me 2z? A z. 2 times what gives me 16? An 8. Okay, so now I have 3 things multiplied together. Now the reason I say we don't normally write this is because when you end up with a monomial, whether this is 2 or if it's 2z squared, whatever, as long as there's not an addition or subtraction, we always put the monomial in the front. So your answer is more likely to look like this. Okay, now this is all multiplication. This is overall a multiplication problem. Think about plugging a number in here and here. We would do the subtraction, we would do the addition, and then we take our answers and we'd multiply them all together. So our last step would be a multiplication. So this is a factoring, okay? And this is factored completely because nothing else can be factored out of either of these two. It does not matter when we're doing multiplication what we multiply together first. I can multiply these two together first, take that answer, and then multiply here. That's the reason why I can move this monomial into the front and it doesn't change anything. Okay, now this problem is very, very similar. Its biggest difference is that we have a minus sign right here. Now, what difference that makes is that we're going to have a minus sign here once we factor out, and when you have minus signs, you cannot just drop the parentheses. So we're going to have to remember to distribute just before we simplify. Okay, if you look here, we have a 3x plus 2 in both of these. So that's my GCF. It's 3x plus 2. So that's what I'm going to factor out. Okay. And from this first part, that leaves me with an x minus 4 minus, and I'm going to have an x plus 8 here. Okay. Now we know that this is a negative 1 here, and so we need to distribute here. So this is 3x plus 2 times x minus 4 minus x minus 8. Okay, so here I have x minus x, that cancels out, and this whole thing is just going to be a negative 12. Now we normally write a monomial in front. This is 3x plus 2 times negative 12, and we would normally write that negative 12 in front so that we get this. Okay, so all of this was GCF. Now we're going to talk about factoring by grouping. If you look at your factoring guide, the first step is always to factor out the GCF. Okay? Always, always, always. It has to be done eventually, and it always makes things easier if you do it first because you'll end up with smaller numbers, smaller variable parts. Okay? Then after you've looked to see if you have a GCF, then you're going to ask yourself, do you have 4 terms? And if you have 4 terms, you're going to try to factor by grouping. Okay? Here we have 4 terms. We're going to factor by grouping. Okay? I look at this entire thing and decide whether or not I have a GCF. I just pick 2 of them and look, 10 and a 1. Since this is a 1, there's nothing I'm going to be able to factor out of these 2 numbers and have it mean anything. Although we can always factor out a 1 if we need to. Okay? Now look at your variable. This has an m, and not all of these have an m, so I can't factor out any variables. Because if this is only an m and this one doesn't have one, then I don't need to check to see if this one has an n or a k, because it's definitely not. Okay, so now we've checked to see if there's a GCF and there's not one. Now we want to factor by grouping. There are a couple of ways to talk yourself through this. What I suggest that you do first is you get a plus sign in the middle. Now there are a couple of ways you can do this. Sometimes you can rearrange things so that that plus appears there. It might be that you need to rewrite something as plus and negative instead of a subtraction. Any which way, you need a plus sign in the middle. And then once you have that plus sign in the middle, you're going to group your first 2 together and then group your second 2 together. Okay? These can be parentheses. I just find it easier to put in brackets in something that's printed, and that way it's easier for me to not write over something and then make it hard to see. Okay, so now I work these as 2 separate problems. I'm going to factor out the GCF of this one and then factor out the GCF of this one. If I look at these 2, I can factor a 2 out of both of these. These don't have the same variable, so there's nothing I can do for that one. So if I factor out a 2 from these first 2, that leaves me with 5m plus 1n. Okay, plus. You do not want to lose this plus sign. This plus sign is this plus sign. Okay? Now look here. What do I have in common? That's a 1, that's a 5, so there's no number part. There's no m here, but there's a k in both of them. So I can factor out a k, and that leaves me with 5m plus n. Okay, now if factoring by grouping is going to work, you should end up with the same thing here and here. Okay, and we do. Now, what we have here is a simpler version of these two problems. Here I have a 5m plus n on both of these, and I can think of factoring that out. I think of that as my GCF. If I factor out a 5m plus n, and think about distributing it with something. Here, I was having to multiply each by another binomial. Here, I'm just multiplying by a monomial. 5m plus n times 2, this times this, plus this times a k. Now, what I generally do is I say, okay, we factor the GCF out of both of our groups. You should have the same binomial here and here. And then you write this down once, and you make a binomial out of what you have left. Then you double check to make sure you don't have a GCF and that nothing factors any further, and we don't have that here. So this would be our answer. If you multiply this back out, you should end up with this.